The third question says, an object of mass 15 kilograms is at the point of sliding down a plane inclined at 30 degrees to the horizontal. Find the force parallel to the plane required to make the object to begin to move off the plane, given that gravity is equal to 10 meters per second squared. The first thing we have to do is to list out all the values given in the question. Mass of the object, 15 kilograms. The object is said to be on an inclined plane of an angle 30 degrees to the horizontal. In this case, we can find the coefficient of friction using tan, the angle given. So we say coefficient of friction equals to tan 30 degrees. Gravity, 10 meters per second squared. So we've listed out all the values given in the question. The next thing is to draw the motion diagram. Alright, let's go back to the question again. An object of mass 15 kilograms is at the point of sliding down an inclined plane at 30 degrees to the horizontal. Inclined plane. Angle theta to the horizontal. Vertically downward, we have the weight mg. Here we have mg cos theta, and the line vertical to this is a normal reaction. So in this case, we have to find the force parallel to the plane required to make the object to begin to move off the plane. We have the natural force that brings the object downward, which is mg sine theta. That's the parallel force down the plane. And the question says, we asked to find the force required to bring the object off the plane. So here we have our pulling force. For us to have our pulling force here, there must be a force trying to pull it downward, which is frictional force. So we have two forces here trying to bring the object downward. The natural force, which is the parallel force down the plane, and the frictional force that is going against the direction of motion, or that is going against the direction of the applied force. So the applied force is balancing the two other forces trying to bring the object downward. Or we say these two forces are balancing or are preventing the object from moving upward. So the resultant force in this case is for the object to begin to move off the plane. This force must be greater than the two other forces. So we say this resultant force is equal to applied force minus frictional force plus mg sine theta. So what's the value of our frictional force? We can also say, okay, let's find the value of our frictional force from the formula of coefficient of friction, which is U friction over normal reaction. In this case, we make friction the subject of the formula. Then we have F is equals to U times normal reaction. Substitute UN or U times normal reaction for F in this case. Substitute F for U times normal reaction in this place. So we say R is equals to P minus U times normal reaction plus mg sine theta. So U times normal reaction. In this case, the normal reaction is parallel to this component here. So we say the value of our normal reaction is mg cos theta. Then R is equals to P minus U. U is equals to tan theta. U is equals to tan theta times normal reaction mg cos theta plus mg sine theta. That is, we replace un with this. U, which is the coefficient of friction, is tan theta. And n, which is the normal reaction, is equivalent to this component here. So we say n is equal to mg cos theta. Then we move on to writing our formula. Resultant force. Yes, says the question says find the force parallel to the plane required to make the object to begin to move on the plane. The object hasn't moved. Then we are asked to find the force that will make the object move upward, but the object hasn't moved. That's the thing we have to know. The object hasn't moved. But the question says find the force required to move the object. So since the object hasn't moved, our acceleration is 0. And when our acceleration is 0, our resultant force is going to be 0. We take this this equation here, we take it to the other side. So this minus will be eradicated. Then we have tan theta times mg plus theta plus mg sine theta. Close the bracket. Then we have equal to p. The p remains. This comes to this place, to the other side of the equal sign. So therefore we can say our p is equal to tan theta times mg cos theta plus mg sine theta. So when we substitute with this formula, when we substitute these symbols, each of these symbols, for the values given above, we are going to arrive at the final answer, which is 150.3 Newton. The value of the force required to move the object on the plane is 150.3 Newton. So when we substitute these values, or each of these values, for the values given in the question, we are going to arrive at the final answer, which is 150.3 Newton.